We'll be talking about Hooke's law and its implementation involving a spring, and also how to find the amount of work done on or by a spring using Hooke's law. Hooke's law is equal to F equals K times X. This equation gives us the force required to stretch or compress a spring. X is the displacement of the end of the spring, and K is a spring constant, which is measured in Newton meters. Now here we have our first example, which is a spring having K equals 200 Nm is stretched by 10 centimeters. And our first question is, how much work was done on the spring? Now we find work by taking the derivative of Hooke's law, which is half times K times X final squared minus half times K times X initial squared. Now here we have all our information, and we plug it into our equation as you can see. And since X initial is 0, half of the equation is able to be cancelled out. And when plugging the rest into your calculator, you get the total of 1 joule. The reason this work is positive is because both the force and the direction are in the same direction. Now moving on to question 2. How much work was done by the spring? Since we know that the spring being compressed or stretched 10 centimeters gives you 1 joule of work, we know that the answer will be 1 joule. But the reason it is negative is because the spring wants to go this way, but the force is being applied this way, which gives you negative work. Now for our third question. Suppose that instead the spring was being compressed by 10 centimeters from its equilibrium state. How much work was done on the spring? As I said earlier, we know that the spring being compressed or stretched by 10 centimeters will give you 1 joule, and since both the force and the direction are in the same direction, this gives you 1 joule of work, and it is positive. And for our fourth and final question, if you perform 5 joules of work on the spring in order to stretch it, what would be its change in length? Now we use the same equation as we did in our first problem, but instead of filling in the value of x final, we leave it as an unknown variable. And since x initial is still 0, half of the equation is still able to be cancelled out. Now using the basic algebraic manipulation, we can get to the square root of 10 over 200, which gives you 2.22361 meters or 22 centimeters.